Hello and welcome to today's webinar. The topic, Logical Data Fabric Powered by Data Virtualization, an overview. This event is presented in partnership with our friends from Denodo. Thanks so much for joining us on this webinar produced by Actual Tech Media. We've got a great event lined up for you here today. Before we get started, there's just a few things that you should know about the event. My name is David Davis of Actual Tech Media, and I'll be serving as the host. As always, we want these events to be educational, and we encourage your questions there in the questions pane of the audience console. We also have a best question prize. I'll talk more about that here in just a moment. Many of you have already said hello and good afternoon, and we love to see that from our audience, but we also want your technical questions on today's topic. Now, I also want to call your attention to the Handouts tab. It's there that you'll find additional information and special resources on the solution that you'll be learning about on the webinar. So make sure that you check that out. At the end of today's event, I'll be announcing the winner of our Amazon $300 gift card. If you're watching this recorded or on demand, of course, the drawing has already occurred. The prize terms and conditions can be found there in the Handouts tab. And then, as I mentioned, we also have an additional prize for another Amazon gift card, a $50 Amazon gift card. But you must ask a question to be entered into this prize drawing, and of course, meet the Actual Tech Media prize terms and conditions. All right, and with that housekeeping out of the way, it's now time for me to introduce you to today's expert presenter. Welcome to Saptarshi Sengupta, Senior Director of Product Marketing at Denodo. Saptarshi, it's great to have you on the event today. I'll hand it off to you. Take it away.
Thanks for that kind and nice introduction. Welcome, audience. Super excited. I have delivered this particular topic in the past a few times, and I'm happy to kind of share my perspective on data fabric and logical data fabric, specifically powered by data virtualization today. So what we are going to do together in the next few minutes is that we'll talk about the need for data fabric. I'm sure some of you, if not all of you, have heard the term data fabric and maybe data mesh in the recent past, and then maybe you are already kind of dabbling with it. You were kind of tinkering with the idea, what a data fabric is, how does a data fabric look like, what is you probably have heard about the term logical data fabric, and if that is the case, what is the difference between logical and physical data fabric, and how people or your organization specifically can get faster time to value, time to market, and a lot of ROI based on the deployment of a logical data fabric. We'll touch upon a customer case study who have used Denodo platform specifically very successfully to create their logical data fabric. I mean, there are many such customer examples, but that is one of my most favorite, and you will know why. And then we'll touch upon what is the best practices to get started. Different organizations at different stages of maturity in their data and analytics journey get started on logical data fabric journey. So we'll talk about that, and then we'll be more than happy to take a few questions, and Lisa will talk about the next steps. So the need for logical data fabric, I'm sure this spaghetti diagram you have seen multiple times in one shape or the other. And this is the reality till date, right? So when you have businesses all over the world, you have businesses across cloud boundaries, like some stuff on premises, some stuff in the cloud. In fact, within the cloud, even if you have moved entirely to the cloud, there are so many different repositories of data, like that can be database, data warehouse, data lake, cubes, files, streaming. There is no end to it, right? Everybody is dealing with data to make business decision or do something within their organization these days. On the other side, you have data consumers, right? You have data governance tools, you have BI dashboarding tools, reporting tools, data science tools, machine learning apps, mobile and enterprise apps. We constantly are using mobile devices, and then microservices apps and all. And this spaghetti diagram is the reality. I mean, the distributed nature of data is the reality. How much ever as an organization we try to consolidate data, it usually is distributed, and there is a lot of point-to-point connectivity, right? So that's a problem. We all understand that, because today you have 5 different data sources, tomorrow you have 5 other. Today you have 5 different consuming applications, you have five different ones or five new ones tomorrow, and you are constantly doing a lot of coding, making point-to-point connection, and that's the problem, right? So that's where comes the idea of data fabric. Before getting into logical data fabric, let's talk about what is a data fabric. Data fabric can be designed in many different ways, logically or physically. Now, a data fabric, according to Gartner, is a design pattern, is an architectural approach by which you can automate the design, integrate, and deploy data objects, regardless of deployment platforms and architectural approaches, right? So it's basically a very flexible, what Gartner talks about is composable architecture, where you can take different tools and technologies, club them together to create this data fabric. And what it does is it actually results in faster, informed, and in some cases completely automated data access and sharing. And you will see in the data fabric design, whether the way we define it, or Forrester defines it, or Gartner defines it, whoever defines it, there is a lot of AI, ML, and automation in a data fabric design. So let's take a look at what a data fabric really is in layman's term. Before getting into the nitty-gritty details, we just want to make sure that you understand how a data fabric is defined at a very high level. So data fabric, as you can see, is like a net or fabric. The term is like that, where that net actually connects different consumers, like and different entities, like products and claims and customers and compounds, and which can vary organization to organization. And that connects to all sorts of data repositories and applications, and that can be cloud data sources, data lakes, traditional analytics and BI applications, RDBMSs, and apps and document repositories. These are some examples. Basically, a data fabric kind of talks to the source data system, integrates those data to get an integrated view, and then for analytical and operational purposes delivers that data and gives access to that data to end consumers. And in the process, the data fabric is supposed to automate the entire, like that kind of source access, integration, data preparation, data orchestration. All those things are automated as much as possible, and using AI, ML, and machine learning and artificial intelligence, right? That's the high level concept of data fabric. And why you want to kind of deploy a data fabric. The data fabric benefits are multiple. Sorry about that. So just skip through it. So according to Gartner, through 2024, manual data integration tasks will be reduced by up to 50% through the adoption of data fabric design patterns that supports augmented data integration. That's what Gartner says. On the other hand, Forrester says that they see a persistent trend of data fabric initiative across industries, including financial services, retail, healthcare, manufacturing, and the list goes on. Basically, what any organization, whether Gartner, Forrester, analyst organization, vendors like us, or our customers, whoever is dealing with data fabric, they'll really see a huge benefit and ROI through the adoption of data fabric, by reduction of manual labor, manual tasks, a lot of hard coding, etc., etc., easy access to data, easy way to doing data preparation, etc. And the Forrester quote is all about how data fabric is applicable across industries. Whichever industry you are in, financial services, retail, healthcare, manufacturing, doesn't matter. A data fabric, when you are dealing with with data as an organization to make insights or data-driven decision making, data fabric design kind of helps you a lot, and it's kind of becoming a must. Now, what constitutes a data fabric? We spoke about that high-level concept of data fabric. We see there is a huge benefit of data fabric, and maybe you're at this point thinking, how do I start with designing a data fabric, right? Maybe you already have quite a few of those components of data fabric. So if you look at how Gartner defines data fabric, it starts all the way from south to north, data sources. You have data scattered everywhere. And then you have on the northbound, there is data consumers. Between that, what you see sandwiched is the definition of data fabric. And as I said, it is a composable architecture. So let's say you have an augmented data catalog. you have data and metadata at your disposal. You have data integration piece sitting somewhere where all the data is integrated together. You have a knowledge graph enriched with semantics. So basically, the semantic layer is becoming even more critical, because these days data literacy and people tinkering with data is very broad within any organization. If you see, C-level executives are making decision with data, business users are making decision with data, there is data scientists, citizen analysts, citizen integrators. So everybody is talking data, dealing with data. And so semantics consistency is very, very important, where IT has their own way of dealing with data and talking about data and nomenclature. Business users think about the same data, but very, very differently. And even though this is out of scope, like when we talk about this other term, data mesh design, where we talk about domain knowledge and creating data as a product, that's because people understand their data within their functional expertise the best possible way, which probably sometimes does not get translated to IT's definition or IT's understanding of data. So all these different business personas or IT personas and technical or non-technical people need to understand the data in their own way, dealing with the same data. Another very important piece is active metadata. So with metadata activation, what happens is that now you can make your machine learning and models, create your machine learning models, and bake in some AI, where if you have a really strong data fabric design, the data fabric can suggest to you certain things. For example, it can give you recommendation about which data set might be useful for you. Let's say we're trying to do some performance optimization and performance improvement. If your data fabric design is done the right way, the data fabric can suggest how you can improve performance. You can probably sometime virtualize data, you can sometime materialize the data, etc., etc. So which particular cases are useful in what type of data integration, with what type of data integration design, right? So all these things can be done with metadata activation and a recommendation engine. Now, last piece is orchestration and data ops, which is extremely, extremely important, because a lot of organizations are moving to the cloud. Some organizations have entirely probably moved to the cloud, or some organizations are in a hybrid cloud mode. Some are like starting to think about like their initial phases of cloud migration. They're using SaaS applications and all, and orchestrating all of your data setting everywhere is or not only data, like I mean your infrastructure actually. So that is very, very important and key element, and so that should be very well integrated with in the data fabric design. And every step, like whether it's data orchestration, data ops, data preparation, your data cataloging or augmented data cataloging, every stage should be automated as much as possible. There should be a lot of AI ML baked into it. And if you look at Forrester's definition, they say the exact same thing. I mean, they probably have their own definition, but looking at it, you can see when it comes to data management, like whether metadata, data cataloging, data security, governance, processing, quality, lineage, everything has a lot of AI ML baked into it. So if you really do a side-by-side comparison, Forrester is saying exactly what Gartner is saying in their own way. It is all about data ingestion, streaming, data processing, persistence, orchestration, discovery, data access. But every stage has a lot of automation and AI ML baked into it. And that's exactly what a data fabric is. So hopefully, with these two sets of definition, you probably have got an understanding of what a data fabric is, right? Now, at this point, we have discussed why need a data fabric, what is a data fabric in layman's term, and what constitutes a data fabric in a pretty broader way. The debate sometime is how you create a data fabric. Like there are multiple different pieces playing together to create this data fabric, right? And one of the key elements is, do you want to store the data in one single repository consolidated, or do you want the data to be distributed, or more than one thing, what is the reality actually? So this slide kind of captures that reality, right? In the 1980s, it was all about databases and ERP systems. In 1990s, there came operational data store and data warehouses, because you have too many databases, ERP systems, and this and that. So you wanted to consolidate that data so that you have one place to go, your data is ready, and you can do analytics, reporting, whatever you want. But those things were really good for structured data. As soon as data became semi-structured or unstructured, mostly with social media data, the big data, streaming data coming from field, etc., things became more complex. And that's where the whole idea of data lake came into fruition, that you are dumping a bunch of your data that are not clean, normalized, and that are not structured in a particular place and in your data lake, and then you figure out, as a data scientist or whoever you are, how you can use that data in the future. With the mainstream adoption of data science and all, and I know you guys know this better than I do, is now you have data lakes, and data lake is a real thing. Every company has a data lake put together, whether in the cloud or on premises, so that your data scientist or those kind of personas can play with that data, do some really advanced analytics, and do whatever they need to do and tinker with the data, right? So while this data lake came into prominence, data warehouse has always been there. Now data warehouses are moving to the cloud. We still think, as an organization, and many of our customers absolutely agree to that, most of our customers, that uh, centralizing data is almost a myth, right? So I mean, data is always going to be decentralized. For smaller organizations, sometimes they can get away with one data warehouse or one data lake sitting in the cloud or on premises or whatever it is. In most of the mid to large size enterprises and organizations, the reality is that your data will be distributed. You will mostly have a data warehouse, you will have a data lake, maybe multiple data lakes and multiple data warehouses, and beyond those you will still have some other source systems and some SaaS applications and everything in the play. In fact, the reality our customers face when they move to the cloud is that, hey, I move to AWS or Azure or whichever cloud, my data is still distributed within that CSP, within that cloud service provider, because there are so many repositories within the cloud service provider where certain one type of data or the other is sitting somewhere. So decentralization of data is the reality. That's what we are trying to say. When you try to kind of put everything in one place, monolithic architecture, the problem is that not only takes time and effort, it is extremely difficult to maintain, as we just now described, and it becomes incompatible. As we looked at the spaghetti architecture earlier, many of you probably have been in the industry for 15, 20, 30 years, and you probably have seen yourself within your organization how things change time to time. Like today, Snowflake is talking about cloud data warehousing. Tomorrow, Databricks will talk, or they are doing their own thing. There is a cloud service provider data lakes and data warehouses, for example, Amazon Redshift and all. And you have your on-premises, maybe homegrown applications, etc., which are creating your data warehouses and data repositories. So when you have such a distributed and complex data ecosystem, putting everything together in one single repository, even these days, there are companies who are talking about this lake house concept. That sounds great to me, but when I talk to our customers directly, they say, yeah, lake house is fine. I mean, I will have a data lake and data warehouse engines sitting side by side, but I don't see that taking away all other data repositories that I have everywhere, and my applications are distributed. Different people use different applications, so that monolithic architecture, everything connecting to one single data repository, is a wishful thinking. It's not going to happen. On the other side, now if you think about logical architecture for data integration and data management, which basically means an approach like data virtualization, where your data integration is more about virtualizing data and creating these like virtual views and etc. So that's where the whole idea of putting all the data together, physical data consolidation, goes away. And what's the beauty of it? Like if you think about a middle layer sitting between the applications, consuming applications, and data repositories, which has all the intelligence baked in, and where all your business logic, security logic, governance logic can be kind of consolidated. The logic is consolidated. You can centrally manage the data, govern the data, secure the data, but you are not putting the data together in one place. It is extremely business friendly if you think about it just conceptually. It's extremely simple, and it will have a unified semantics, as we spoke about earlier in the data fabric concept of data fabric design, unified security governance, and it's expressed in terms of business logic or business language, because as we spoke about it, a semantic layer is integrated in that particular logical architecture. And the last but most important point is future proof. We have customers where they will talk about, hey, that technology evolution and infrastructure change, that's going to happen all the time, but they say once we have deployed a logical architecture, something like Denodo's data fabric architecture, I really do not think about how my other team members are changing their applications or changing their underlying infrastructure, source system, etc., etc. Today we are on premises, tomorrow we are going to the cloud, our data is distributed across cloud and regional boundaries. I don't care. I have this logical architecture layer where I just make some simple changes, and that just connects to new data sources and new applications, and bingo, I'm good to go, right? So that's the beauty of the logical architecture. And so with that, this is kind of a very high level idea of a logical data fabric, as we say. So it's like we are talking about our platform here because we are part of like Forrester's data fabric wave, and Forrester considers us as a unified data fabric design. Gartner also talks about our platform as a data fabric. But you get the idea. What I'm trying to convey to you is that a data fabric in a simplistic term should look like this, where all your data sources are on one side, all your applications are on the other side. In the center, however you want to put your data fabric design, it's, as I said, it's a composable architecture. I mean, if you take a platform like Denodo, you will get all the components of a data fabric through one single platform, but it's up to you how you want to define the data fabric. And you can take one type of data integration tool or one type of data preparation tool, one data orchestration tool, a semantic tool, club them together to create your data fabric. Of course, when all the components are well integrated through a single platform, that makes your life so much easier. They give you the best performance and best of breed performance, and like value for money, right? So this is the high level concept of data fabric. It's logically integrates, manages, and delivers all of your distributed data to all your end users. And the other good part of it, it is platform agnostic, or platform environment agnostic. You are on premises, you are cloud, you are multi-cloud, containerized, whichever way you are dealing with your data. A good logical data fabric design can solve that problem. How your data sources and data consumers are shaking hand, talking to each other, and getting that insights that your knowledge workers need, right? Just to quickly touch upon some of the key capabilities of a data fabric that we at least offer is, we spoke about the AI ML recommendation and automation. It's a key component of a data fabric. Advanced semantics and active data catalog. Think about the data catalog as what the data catalog, at least the data catalog we offer, can do for you is, think about your shopping experience on Amazon or your Netflix movie watching experience. So the active data catalog or metadata activated data catalog can give you recommendations. So think it in terms of enterprise context. When you watch a movie in Netflix, it says, if you like this movie, you may like this movie too. When you shop on Amazon, it says, okay, if you bought this product, maybe you want to buy this other product along with it. That's how others are shopping. Or they will say, okay, these are the alternative products you may consider. Think about that in terms of enterprise data context, how beautiful it will be. You are a data scientist, you are a citizen analyst, you are a business unit lead, or you are a C-level executive. Doesn't matter, whoever you are. When you are dealing with data and you need some recommendation, hey, am I looking at the right data? Is this the right data? or what can I do with the data, etc., etc., you get really list. In fact, again, out of scope for this particular presentation, if you look at our Denodo platform data catalog interface, it will talk about which data sets are trending, which data sets are being used by whom, which data sets are getting kind of recommended by other users, which data sets are getting deprecated. So if you are really dabbling with data or dealing with data on a day-to-day basis, that will be a beauty to your eyes. Unified security governance is very well integrated to our platform. Real-time data integration is extremely important, right? So when you are dealing with streaming data, social media data, etc., on a day-to-day basis, as you know, those data's lifetime value, I mean lifespan is very short. Like social media data, what's trending now is not going to probably trend half an hour from now. Streaming data, whatever you need to you need to make a decision in split seconds, and that data is coming from your car or your device, connected devices and whatnot. Unless you can integrate that data in real time and make a decision based on that data, the value of the data goes away, and that's where the legacy technologies like ETL and stuff fall short. Smart query acceleration, this is very specific to our particular platform. What happens there is that, as I said, like you can use metadata activation for accelerating your query. You are looking for some data, and this is one question that comes to people's mind all the time. They will be like, when I talk to our customers or prospects rather, they'll be like, okay, I'm very happy with my ETL so far. Now things are going out of control because we have so much data, and I'm looking into a logical data fabric with data virtualization as the main data integration technology. How fast is your performance? How good are your performance? And there are very many technologies that is baked into our platform. Like, let's say we have MPP acceleration technique, we have caching technique, etc., etc. The latest addition to it is the smart query acceleration, where you if you have 2 3 different type of query going through the platform, and these queries have some similarities in nature in some intermediate step, you can say, okay, I want to materialize the data so that next time when I do the same query or similar query, it's much faster execution. And that has given a tremendous boost in terms of performance for our query. And so we actually have benchmarked our query optimization techniques, and it is as performant as like if you create a physical data repository or data warehouse or something. And finally, logical data abstraction, that's another key important thing. You don't want your business users or end users to get bothered by what's going underneath in the infrastructure level. Data is today on premises, tomorrow in the cloud, multi-cloud, wherever the data resides, a business user should not care about it, and they don't have to go to IT organization to talk about the availability of the data, where is the data, etc., etc., static reports and all. Instead, like whatever IT is doing, let them do that. Whatever business user need, let them get that in the fastest possible way. And data fabric is the sits in the middle to basically solve that problem. This is just an exact same architecture that I showed earlier. That was a high-level architecture. This is a little detailed architecture. So some of you who are very technical in nature in your work, you probably can relate to this. So all your data sources sit in the southbound. We have like 150 plus data adapters. So you can think about any data source will be able to connect to it. If you think about the consuming applications, we have data catalog through which many of our customers actually consume the data going through the data catalog. We have a SQL interface. We have a lot of wizards like drag and drop capabilities. And whether you are a data scientist, you are connecting a data science tool or a BI tool or anything through the SQL interface, you can do that very easily. And finally, you can actually consume the data as a service, web services like RESTful, OData, GraphQL, GeoJSON, we can support everything. So it's a very broad set of connectivity that we offer, southbound and northbound. And within the Denodo platform, we handle all the things that we already spoke about. I have these two architectures just for a quick glance. I'll not spend much time in it, but a lot of you probably are dealing with data where you have moved a lot of your data to Azure platform or a lot of your data to AWS platform. So how do you visualize the data fabric that we showed you so far? How you can uh, kind of think about how the future will look like if you want to consider a logical data fabric by deploying Denodo. In the Azure platform, this is how it looks like. So on one hand, you have your MS SQL Server, Excel, you probably, again, as we said, other data sources, right? Why, even when you moved into Azure ecosystem, you probably have some SAP, some data sitting in SAP, Salesforce, or wherever, third-party tools and all, right? And probably you are then moving that data to Azure Data Factory or Azure HD Insights Kafka. Now, when you connect that to Denodo, there are multiple ways of connecting to Denodo, as you can see. It can be passing through the Azure Cosmos DB, the Azure Synapse Analytics, or Azure Data Lake storage, etc., or even Databricks. Then it talks to Denodo. So basically, however you want to architect your internal Azure data infrastructure, if everything passes through Denodo platform, as we spoke about it, Denodo at that point acts as that logical data fabric where all your business logic, all your compliance logic, all your data governance and security logic is baked into that one single platform for semantics, for data orchestration, for data integration, everything. And you are not uh, putting all your data in one particular repository or trying to put all your data in one particular repository. Everything can still be very distributed in nature within your Azure ecosystem, and everything can pass through Denodo, and ultimately those can talk to Power BI or Azure Analytics Services, or even any other applications like real-time apps or mobile apps and all. So hopefully, if you are in Azure ecosystem, even if the architecture that you have doesn't fit exactly the same way, but I think you can connect the dots and make sense out of it. How you can create uh, uh, the concept of logical data fabric using our platform or something similar to ours to create that data fabric design, right? Same goes for AWS. So if you are are mostly into AWS ecosystem, you probably have Salesforce applications, MS Dynamics, and then you still have SAP and Microsoft Excel and other applications. And then again, within the AWS ecosystem, you probably have Amazon Kinesis, Glue. You have all sorts of like AWS data sources, Aurora, DynamoDB, and all. But everything at the end of the day, if it passes through Denodo, that makes your life very easy. Just a quick example here. One of our very large customer, one of the largest semiconductor companies in the world, for privacy reason, I cannot take their name publicly, but they use Denodo. And the way they use Denodo, they have been using Denodo for 7, 8, 9 years now. uh, they have built in this inside the entire company, this logical structure where everything has to pass through Denodo, almost everything. So they have certain cases where Denodo has everything has to be like, that's like tier one kind of use case for us. And then if you hit certain limits, then maybe certain applications can directly talk to the consuming applications and all. But mostly they try to make everything pass through Denodo, because that way, the way we spoke about the logical data fabric architecture, that makes your life so easy. In the future, today you are in AWS ecosystem, Azure ecosystem. Tomorrow, who knows, you will change to some other ecosystem. Today you have certain number of applications and repositories. Those can change in the future. If your business logic is baked into Denodo or a logical data fabric platform, your future, you become very future proof. That's what we are trying to convey here. And within the as AWS or Azure ecosystem, how you can make your life easy, right? Um, Very quickly, a debate between physical and logical data fabrics. We keep hearing about this idea about, we talk about logical data fabric. We described it, we told you what. And physical data fabric is when you have everything consolidated physically, data is consolidated physically, right? And they have their own sweet spot use cases. So there is almost never a case of whether I should physical data fabric or logical data fabric. If you create a logical data fabric, within that also you can have a physical, or not can, you should, will always have, I mean, data is not going to sit in the thin air, right? So you will still have a data lake, or multiple data lakes and data warehouses and other source systems. The idea is, are you going to consolidate all those things also, or you create a logical layer on top of those physical data repositories, right? So on the left hand side, what you see physical data fabric is when your data is literally consolidated. There is no logical layer on top of it. This has its sweet spot when the analytical needs are the analytics needs storing data in different schemas. When operational needs demand storing data for data management needs, for example, MDM systems and all, right? So in those particular cases, you have very heavy transformation needs, etc., etc., and your physical data fabric is a good design to approach to go for. The problem with that kind of design is that it is not an enterprise data layer. As we spoke about a logical data fabric, it actually creates a fabric end to end, and that's what kind of holds everything together. In a physical data fabric world, you are almost always going to fail, unfortunately, because even if you consolidate a lot of your data in one place, you'll still have data residing somewhere else. Whereas in logical data fabric, you can easily unify all of your enterprise data. You are not replicating data, extremely good for regulatory purposes and compliance purposes, because we know that there are compliance problems like GDPR, GRC, and the list goes on, where they say that this type of data cannot be replicated over regional boundaries. The same data cannot be replicated multiple times for PII purposes, etc., etc. The only reason why you may not want to think about logical data fabric is that when the heavy transformation and subsequent persistent need is, that's pretty much the dominant use case. So if you have one particular use case where you have really heavy transformational needs and heavy persistence needs, for that one particular or two particular use cases, you may think about physical data fabric, consolidate your data. But even with that, you will probably have multiple other use cases that are the right use cases for a logical data fabric. So think like that. I'd like to think that will help you in logically coming to a conclusion how you want to create your data fabric, right? And physical data fabric and logical data fabric, from benefit cost standpoint, data is readily available in physical data fabric. We know that. The only drawback is that it takes a long time to kind of consolidate your data, bring data to one particular repository, and costs are extremely high, as you probably can understand, because you are replicating the data, keeping the same data again and again in different repositories. And data can get out of sync very easily because you are replicating data. The master data sitting somewhere, or the golden state of data, is probably not reflected in other repository that you created, and they can get out of sync. Whereas in logical data fabric, there are a couple of costs like or like repeated transformation takes time, etc. But the data delivery is super duper fast. It's real time, as we spoke about it. There is no replication of data. You're very easily compliant with data regulation rules, etc. And data is delivered in real time, fresh from the source. So you are always looking at the data as it comes from the field or wherever it is coming from. Now, there is a myth that logical data fabric is slow. And as I spoke to about it earlier, everybody thinks that, hey, I'm going to send a query right now, and it is going to then talk to other systems and all, and then get back to me with the answer. So it's going to take time. But given how much we have spent, like more than 2 decades, in kind of making the data, the performance faster, the query performance faster with so many different techniques like push down optimization, the caching, the MPP acceleration. Recently, we baked in that aggregation awareness, smart query acceleration, and all. So it is as performant as a physical data fabric. So that's kind of, in a nutshell, how to think about a data fabric design. What is data fabric? What is logical versus physical data fabric, and how to create, what constitutes the logical versus physical data fabric and their drawbacks and benefits. This is just a quick touch upon one of our customer use case, lease plan, just to give you a sense of how in real life a logical data fabric may look like. So lease plan is a leader in fleet management. As you can see from the stats, they have been around for a very long time. They have presence in 32 countries. Number one EU reseller. They basically what they do is they lease these cars, as you can see here in this particular chart. They purchase a car, they finance it, they insure the car, they maintain fuel management, all the way to the end when they basically finally sell that car to carnext.com, their sister concern, right? So in that process, their business problem or even technical problem was that they were always in a reactive mode. If you and I mean, even if I think about how I have leased a car in the past, and I'm sure some of you have leased a car in the past, and whether it's a leased car or your own car, we have always been, or our like car manufacturer, I mean, or dealership and all, they are very reactive in nature. When something breaks down, let's take care of it. That's how we most of the time take care of our car. Scheduling this periodic maintenance, which again has become very mainstream for the past few years, it is very helpful, so that on a periodic maintenance, like you can kind of avoid some of the breakdowns and all. But and then you can do some proactive stuff where you take it to the body shop, or rather your kind of service department, and they proactively tell you that hey, this is something that may get fixing, this is where you take an early decision, etc., etc. Those are all good. For a car company or car leasing company like LeasePlan, what they wanted to do is, because they want the car to be really in good shape when they sell it to carnext.com, so they wanted everything to be done predictive and prescriptive, right? They wanted to run some really advanced analytics to predict the failures and prevent failures. That was basically their goal, uh, given the nature of the business. So from historical analysis to real-time analysis, that's where they wanted to go. And this is the architecture diagram. So I'm not going to spend any time at all, but I'm sure given who you are, like everybody that is listening to this webinar, you all know how this architecture looks like. The couple of key really takeaways is that, as you can see, these guys have data sources, numerous data sources sitting everywhere. uh, they have this data acquisition layer, data storage layer, raw data stores in SAP HANA and within their AWS ecosystem. And then they have created this analytical warehouse and data science bucket separately, right? Where you have Jupyter, AWS SageMaker, Spark, and on the other side you have SAP HANA, Snowflake, data repository, and whatnot. As I was telling earlier, even if you want to consolidate data in one data source, look at this particular company that is our customer, who has 3 or 4, even if they consolidated the data, the raw data, that is still distributed in SAP, in Snowflake. There are people doing data science. For them, they have created a separate data and analytics flow. So nothing is really consolidated in a monolithic architecture. And that's where the beauty of a logical data fabric comes into play. Because once you put that logical data fabric between the data consumers and the data sources, your life becomes much easy, because you do not know literally whether you're going to be in Snowflake tomorrow or you're going to be in Databricks, whether your data science toolkit will, or data science infrastructure will look like the way it is looking today. You may have some new applications, new vendor coming in, and you may want to change to that. So while you are doing all the good things that you are doing with your data and analytics ecosystem, if you have a Denodo layer between data consumers and the data repositories, all your business logic goes there. You're very future proof. Everything is much more real time in nature. You have an amazing data catalog that can give you recommendation, etc., etc. One quick note here: you see Colibra working with Denodo. Colibra is a standalone data cataloging tool, and we have our own data catalog. Why are they using Denodo data catalog still? And why are they using Colibra? Is because Colibra, as you guys know, is really good for data governance purposes. But when it comes to recommendation and suggestions and etc., etc., those things, as we spoke about at a high level from a data catalog, that's where we shine. That's why, and our data catalog is really well integrated with the data delivery ecosystem, which is not there for Colibra. So you have to feed it the metadata to be able to do what it does, right? Whereas Denodo, as a it has a data integration layer, and the Denodo's data catalog is integrated to it. And that's the feature and benefits these guys, Lease Plan, wanted to use alongside Colibra, right? So this is how a reference architecture may look like in your design. There are various different possibilities of logical data fabric design, where Denodo kind of sits in the middle. On your left-hand side, right-hand side, as I said, you are very flexible to tinker with those. Your infrastructure, your ecosystem, you should be able to define. Just if you put that logical layer somewhere in middle, your life will become much more simpler, much easier. These are some of the key benefits they got out of the data fabric design. I'm not going to spend too much time in that, but at a high level, they presented in one of our annual events, and our champion there, who spoke of the benefits. His point was where we were in terms of reactive and scheduled maintenance to go to this proactive and prescriptive maintenance. Uh, this was absolutely not possible without Denodo or logical data fabric. The concept of logical data fabric, that's the biggest takeaway here, right? And so if you want to deploy something like logical data fabric in your organization, start small. As I said earlier, so determine your business requirements, decide which particular data fabric design is right for you in which particular use cases. Do not think that physical versus logical, whether I should do physical data fabric design or logical data fabric design. I think they go hand by hand. You can still have a corner use case or few use cases where the physical data fabric will be the best option, but putting a logical layer on top of everything is a very good idea given what we spoke already. So there is always a balance of benefit versus cost, and figure out which one works for you. And never boil the ocean, right? Because I'm sure you already have some cloud play in your organization. You have so many repositories. You're moving to Snowflake. You are moving your data bricks, whatever it is. Let those good things happen and keep going. You can take, when you are trying to convince yourself and the rest of your organization if logical data fabric design is right for you, start working with a small logical data fabric deployment, and try to see, just take one or two use cases, try to see if that works for you and how it benefits you versus the physical data fabric design. What are the key benefits it get out of it? And once you convince yourself and to your immediate team members how these things can make your life easy, you can always expand. You can always see there are so many really cool use cases and solution categories a logical data fabric can offer to you. It will be I'm sure it will be a pleasant surprise to you. So with that, I think I'm pretty much coming to an end. Hopefully this was helpful, and you learned a little bit, few things about data fabric design, logical data fabric, logical versus physical data fabric. More than happy to take a few questions, and if I cannot answer all the questions today in the next few minutes we have, always happy to kind of take it offline. So with that,
Thank
back
you. Thank you very much, Sapta. Great presentation. So as we mentioned earlier, and as Sapta just mentioned, we welcome any questions. We do have some that have already come in, so that's great. Just as a reminder, you should see a Q&A tab below the view of the presentation where you can submit a question anytime now. So let's get started with those that have come in so far. There's a question here about data fabric versus data mesh. Are they the same or how are they different?
data mesh, okay. So I don't think I went through details. I just spoke about the concept of data mesh earlier a little bit. It's a very good question, actually. So I think all of us are hearing these terminologies these days: data fabric, what it is, we spoke about it quite a bit, and data mesh. The way I hear is that there is a lot of confusion. People just think that, hey, it's either data fabric or data mesh, two different approaches to data architecture and whatnot. I actually kind of, my opinion differs from that, because what I think is data fabric is an architectural infrastructure approach. Okay, so you design a data fabric to kind of talk to all of your data with the enterprise data and give people access to that data, manage that data, govern that data, etc., etc. It's a composable architecture, as we spoke about, right? So we already went through it in details. On the other hand, data mesh is more of a principle, it's more of a paradigm where you actually are giving more ownership. It's a process orientation also, where you are giving more ownership of data to the people who understand the data the best. For example, any organization, any decent sized organization will have a marketing department, and they understand their data the best, right? uh, there is a finance department, there is an operations department, sales organization, right? So every organization understands their data the best. So if you can let them actually work on that data and create what we call data product, this is not the, of course, the actual product of the company. If it's a product company or services company, whoever they are, data product is more about those data sets, or the final, I mean, in our case it can be virtual views of data, uh, which becomes the data product. So people within certain business units or domains, that's the right term for data mesh design. This domain knowledge is important, and domains create their data product. Then they expose that data product to the rest of the organization to consume. So for example, marketing and sales work together. So sales can create data product that are meaningful to marketing, but sales is the right organization who can create the data product themselves and then surface it to the marketing department. And it's vice versa. Marketing can create data product, they can then share with sales. Now, once people create the data product and they surface that data product, or expose it to the rest of the organization, there comes a concept of this, how to govern the data, right? So they talk about federated data governance, which I think is the right approach, where every business unit or domain or bucket will, whoever is creating the data product, they will have their own governance and security rule. But then there should be a central IT organization who is looking after, or CISO's office, or whatever, who is looking after the security governance and all those good things from an organizational standpoint. They need to kind of work with these different domains to federate their governance need, and then come up with a final governance and security model. So that's the approach of data mesh. So sometimes people say that you can use a data fabric, like with the physical or logical data fabric, to create that enterprise level data mesh. So in my mind, long story short, is that data fabric is more of an architectural approach, an infrastructure play, whereas data mesh is more of a process orientation or a paradigm to think about it. Hopefully that was helpful.
Thank you, Saptam. How about the logical data fabric design? It involves just data virtualization. What should we do if we already have data warehouses or data lakes?
Okay, so yeah, I think I already kind of touched upon that, but I can kind of clarify that one more time. What I meant to express earlier was, and it's again a very good question to clarify. So a logical data fabric, that's what we call it, because so just to again clarify, we actually support many other data integration methodologies. Like for example, we have something very similar to ETL baked into the platform. We support API, we support streaming data integration and whatnot. But data virtualization happens to be the core or main data integration method. So when you have a data lake already in existence, data warehouse in existence, those things can be considered as a physical data fabric if you have all other components tied to it. For example, you have a data catalog tied to your physical data architecture, or you have a semantic layer, etc., etc. But then, as we spoke about it, even with the data warehouse or data lake, you probably have 5 other applications, or 5 other data repositories, or 5 other data sources sitting somewhere. We looked at those reference architecture diagram in the AWS and Azure ecosystem, and we saw that within the Azure ecosystem or AWS ecosystem, they had their own tools and storage pieces, but beyond that, there were other third-party applications and third-party data sources, right? So in my mind, A data virtualization type of an approach to data integration is is the key, is very important to a logical data fabric design. Underneath there can be all these physical data fabrics, if not physical data fabric, physical data repositories. So you can think about that. So the logical data fabric is an umbrella that sits on top of all your physical data repository to create that logical data fabric, and that's how I would think about it, and hopefully that kind of clarifies to you how to think about it.
Okay, thanks on that, Sabta. We have another person who's asking about, they're from the data science team, and they want to understand how data fabric, the design, can help their data science efforts. So maybe expand a little bit more around the data science implications with a data fabric design.
Sure. So 2-3 things, right, can happen from a data science standpoint. So let's say if you are a data scientist, you just need, first of all, you need all the data at your fingertips. In fact, we have a customer, we have many customers using us for data to create that logical data fabric for data science needs. A customer called Prologis, they have a huge data science team who are using our platform to create that data fabric. And how they get help is that, first of all, you need data at your fingertips, and unless you are creating a particular repository for data science team, some sort of a sandbox environment, you actually can gather all of your data, the data you need, and access that data very quickly with a real-time integration with the data fabric, right? So that's number one. Once you have the data, now you're creating your ML models and you're scoring those models, etc., etc. When you expose that data particularly to the rest of the to other teams, or let's say to you yourself, your data science teams are themselves consuming that data or dashboarding with that data, etc., etc., you can expose that data through Denodo platform, as we showed earlier. So that's very helpful. So getting access to data, creating your models, model scoring, etc., and then exposing that data to whoever is the data consumer, the final consumer, both are get tremendous help from data fabric design. Also, in platform like us, we have a notebook, integrated notebook, and if you're a data scientist, I know that you probably use one notebook or the other. We have a Zeppelin based notebook integrated to the platform. So when you are actually taking notes or dashboarding or something like that, you can create your notebook within the logical data fabric design that you have created right now. So there are very many ways. These are some of the examples. We also spoke about the data catalog. As a data scientist, you're probably looking at different types of data sets and whatnot, which your other colleagues are using. And if you want to get some recommendation, if you want to see what others are using from that standpoint, also you can have some benefit as a data scientist. So there are 3-4 key ways I can think data scientists can get help from a data fabric, logical data fabric design, and hopefully that answers your question. Back to
Thank
you.
you, Sabta. Thanks. We have another person who's saying that, they're planning on moving to all of their data to Snowflake, the Snowflake data warehouse. And they want to know, so if they're doing that, does it mean they don't need a data fabric? Will it, how would that help them if the whole data fabric, if
Yeah,
they're moving?
even if yeah, I get the point. So I think the question they're asking is that, so if you are moving all your data to Snowflake, the earlier we spoke about monolithic versus distributed architecture, right? So in this particular case, and then that is a perfectly feasible and practical case where you somehow, maybe you're a small organization or a mid-sized organization, and you have figured out that you still need and you need to move all your data to Snowflake, and that's fine, that works for you. Snowflake will still not have a data catalog. They will not have that. Let's say still you have a few data sitting here and there, and you need to orchestrate that infrastructure or data. Let's say you need a semantic layer, right? So for all those different purposes, even if you're not just integrating data the logical way or real-time way, and you're consolidating all of your data in one particular place like Snowflake, that's fine. Still, you will have all these other pieces that I showed about the data fabric design that will not be available to you. most importantly, today you are moving all your data to Snowflake. I almost can guarantee you, that's how I feel like there will be a change in infrastructure tomorrow, and now you have to move everything that you have moved to Snowflake to another repository or something, or maybe Databricks or something. So I would like to think that is why you still need a data fabric design. Think to everybody's project and scope of project and what you're dealing with, problem set is very different. Think in your context why you need a logical data fabric. I hopefully have given you enough reason that even if you move everything to Snowflake today, why you still need a logical data fabric design on top of it.
I'm afraid that's all the time we have. Saptarshi and Lisa, really great presentation and great Q&A session there with the audience. We do appreciate everyone's questions on the event today. I do want to now announce the winner of our Amazon $300 gift card. This is going out to Aaron Ellinghausen from Oregon. Congratulations, Aaron Ellinghausen from Oregon. We'll reach out to you to deliver that prize, and also our best question prize winner as well. Before we go, I want to give a special thanks to Denodo for supporting us on the event today. I encourage you to check out the handouts tab and their website for additional information. I hope you enjoyed the webinar today. I know I did. We'll see you on our next event. Have a great day, and we'll see you next time. Bye-bye.